All right, my friends, let's take a look. I'm actually going to go through the second column first. So basically in the second column, you see some somewhat common math symbols. Some of these have probably shown up a little more than others. And I'll just go through and make sure you're good with what they mean, and then also comment on a couple common mistakes with some of them. So this first symbol, basically to handwrite it, it's a C shape with a horizontal line through it. A common mistake is for someone to see basically like a letter E and to do something like this, which that means epsilon, that's something else, something different, or some people just kind of decide to capitalize it. And that, my friends, is the letter E. And so that's taken as well as something else. Anyway, so when you draw it, again, it's a C shape with a horizontal line through it. So, and congratulations if you knew that that means element of, or is an element of. I think I'm just going to say element of. Okay. So an example of using this would be to say, 2 is an element of the natural numbers, right? Because the natural numbers are the set starting at 1, 2, 3, 4, 5, all the way up to infinity, essentially. But anyway, so that would be an appropriate, I suppose, use for that symbol. The same symbol mirror imaged, so it's like a backward C with a horizontal line through it. That symbol means such that. Now, depending on your context, sometimes in math, you could also use a colon to mean such that, like in set notation, or just one vertical bar would also mean such that, again, in set notation. But in kind of like a paragraph proof situation, the symbol you see here would be the most appropriate. Okay, basically an uppercase E, but mirror imaged. That one would mean there exists. Let's see. The upside down A means for all. There we go. The 3 dots with a single dot on top, you might recognize that one. We've used that one a bit this year. That one means therefore. Very similar, 3 dots, but the single one on the bottom, that one means because. So that's kind of fun. And then this last symbol, I'd say, is one of the most abused, misused and abused symbols in math. So basically, this one is an equal sign with an arrow pointing to the right. And so this one means yields. So there are some folks, even in our class, who have been using this fairly inappropriately. So you don't want to use this where you should be using an equal sign. So another way of saying this symbol, it means yields or implies. Okay, so let's talk about this one just a little bit, because I've seen this one get kind of used and abused in the past. So let's talk about an appropriate use for it, and then that maybe you've had in the past, and then we'll talk about an inappropriate use for it. So let's see, what's an appropriate use for this symbol? Let's say you're doing a geometry problem, and let's see, can I think of an appropriate use for the yield symbol? I don't know. Let's see you're doing a geometry problem, and I don't know, we'll keep it really simple. So let's say you're finding the area of a rectangle. Whatever. Okay, and then you know that this is 5 and this is 3, and then so you could say something like width is 5 and the length is 3, and that would therefore imply that the area would equal 5 times 3, and that would imply that the area is then equal to 15 square units. Okay, so so basically, like this symbol means kind of it follows that, or what I've got. This information implies what's next. Okay, so that would be an appropriate use for that symbol. An inappropriate use for the symbol would be like, let's say in the work that I've got here, let's say this part right here. It would be inappropriate to say area equals 5 times 3, and then that yields 15. So in here, this would be the mistake because 5 times 3 equals 15. And so it would be more appropriate to just say equals 15, not using the yield symbol there, if that makes sense. So we would say this should be an equal sign. Oops. There. Okay. All right. Still haven't said a peep about mathematical induction, but that's okay. We've learned a lot about math symbols, right? Okay. Let's see, notation. You may have noticed what looks like some repetition here, but I do want to make an important note about the difference in this lesson in particular between N and K. They're gonna this is probably one of the hardest things for people to wrap their minds around. But basically, we're going to use, so let's put a note here. Note. My pen is not working very well today. Okay, let's make a note about the difference between N and K. So when we use the letter N in like a proof of like a mathematical induction proof, basically N is going to represent any natural number. Represents any natural number in a variable sense. So when we say N, we're saying N could be, N should, like our claim should hold true whether N is 1 or 2 or 3 or 4 or anything. So N represents basically all the natural numbers when we use N. But K, let me put a little dot here. So, but K is not representing a variable. K is what's called an arbitrary constant. And it's going to be a little tricky to like feel like you understand the difference probably between a variable and an arbitrary constant. So K represents a single arbitrary constant. So while N is variable, K isn't. K is fixed. It is just one of the natural numbers. We're just not saying which one. And so it's just a single value there. So, all right, so that's the big difference between N and K. So now for notation, when you see A sub N, I hope you recognize that as basically the nth term of a sequence. And then where N would be variable, so N could be any natural number. Now, when you see A sub K, that is going to mean the kth term, where K is a single fixed arbitrary constant. Okay. If you still don't see the difference between those two, it's probably okay, but we'll get you there. A sub K plus 1 means the K plus 1 term. And I hope it makes sense that A sub K plus 1 would, if you were to list terms in a sequence, it would come right after A sub K. It would be the one right after A sub K. Okay, now for the sum notation, S sub N means the sum of the first n terms, or the nth partial sum. Let's see, how do I want to write this? We're going to write this two ways, I think. S sub N basically means your first term plus your second term plus your third term all the way up to your nth term, where n is a variable. Okay, and then the sum of the first, so S sub K means the sum of the first K terms. So that would mean a sub 1 plus a sub 2 plus a sub 3 plus, and then basically k just means some arbitrary constant, so you'd stop at whatever constant that is. I know S sub n and S sub k look extremely similar, but the difference is in, again, n is a variable, k is an arbitrary constant. Okay, so n represents all the possible natural numbers, and then k represents a certain one. Okay, now for S sub k plus 1, this would mean the sum of the first k plus 1 terms. And so S sub k plus 1 is equal to a sub 1 plus a sub 2 plus a sub 3. You'd still have the kth term, and then you'd also add the k plus 1 term. So I hope that makes sense. And then I'm going to make a little room for myself here to make a note. Another way to think of S sub k plus 1 is that it's equal to the part that I just braced out. That's the sum of the first k terms, and then you just have to add in the k plus 1 term to it. So these two are equivalent. Okay. All right, my friends. So now let's kind of switch gears and have you think about an example here. Oops. Okay, so for example 1, let's have you kind of consider, given that the sum of the first n terms is defined as 1 plus 3 plus 5 plus 7, so we're just adding the odds together, plus, and then continue in that manner until you get to an nth term defined as 2n minus 1. I'd like for you to evaluate the following. So the first partial sum, second partial sum, third partial sum, fourth, fifth, and then I've got you considering what happens if I get greedy and want the 12th partial sum. And then by the time you do that, you should notice there's a trick to it. And so that's what I'm asking you there for S sub n. So give this example some consideration and then check in with me in the next video.